Okay, we're going to talk about average rate of change, just to solidify the equation that we're using, the concept. So if I have an equation, y is equal to f of x, the average rate of change will be y, how much the y changes with respect, well, over an interval, because we have to take it over an interval. And the interval is of where we're finding the average rate of change is x1 comma x2. So for the interval of x1 and x2. So y is equal to f of x, and that means that if we want to find the average rate of change, we would find the change of y, we'd find the change of y, which would be equal to f of x1, f of x2, minus f of x1, and we'd have to find the change or the length of x between those two points, which the change in x would be equal to x1 minus x2, which we'll call h. This is the difference. H will be equal to the difference of x. Well, these are supposed to be swapped around again. I put x1, x1, x2 minus x1. We'll call it h. And it would be equal to how much the change of y is with respect to the change of x. So this change of y, this change of y over this change of x, which would be equal to the same thing as this, f of x2 minus f of x1 over x2 minus x1. But we said that was h. So if we were to, we can rewrite this saying that f of x2 is just going to be f of, is just going, as an x2 is just x1 plus h. So we can rewrite this as saying the average rate of change is equal to f of x1 plus h minus f of x1 over h, the difference between x1, x2, and x1. And this is our average rate of change. This is the equation we use to find the average for our average rate of change. This is it. H can't be equal to, h cannot be equal to 0. H can't be equal to 0 because if we got 0, you can't divide by 0. So, h can't be equal to 0. Now, if we were to if I were to graph something real quick, if I were to say, let's just pull shear, right? And I were to give you 2 points, let's say from this point, that will be x1, and this will be x2. So this is x2, and this is x1. If I were to get the change in y over the change in x of this, and for the average rate of change, I'm just getting the slope of a line that passes between these 2 points. That's what I'm getting. I'm getting this y right here, and I'm getting this y right here, and I'm finding the difference between the two, and I'm dividing that by that change in x. So that this average rate of change this average rate of change of an equation, this f of x plus h minus f of x1 divided by h is going to be equal to the slope of this secant line which is the line that passes through 2 points. 2 points. And that's what we're measuring whenever we're measuring this average rate. How much the y is changing, the average of how much y is changing to this with respect to the change in the x. That is what we're measuring, this slope of a secant line. So yes, the average rate of change that we use, the equation is f of x1 plus h minus f of x1. K-State School.